Here's an example to illustrate the quantitative measures of location used in statistics, the mean, median, and mode. Suppose we have the field goals scored by a basketball player in his first 10 games. So in game 1, he scored 5 field goals. Game 2, 6. 5, 4. Game 7 is the highest. 11 field goals. And so on. We can organize the data by arranging it from lowest to highest. We can obtain the average or mean by adding up or summing up each field goals. So this is 10 observations. So the mean is computed by taking the sum of each field goals and dividing it by the number of observations. These are 10 field goals divided by 10. Our mean or average is 6.1. So let's say we treat 4 and 11 as outliers because they seem to be too far from most of our observed values. Then we can remove it from our computation. So that makes it only 8 observations being considered in our average. So here we'll obtain what we call the trimmed mean with the subscript of TR10. So by the way, the symbol for mean is X bar. So trimmed, the subscript 10 here means that we remove the lowest 10% and the highest 10%. With a data size of 10, the lowest 10% is the last one. The highest 10% is the highest one. So remove 2. And here our denominator should be 8 because there's only 8 remaining. So our trimmed mean is now 5.75. If we trim it further, suppose that we consider this 2 as outliers, then we'll have what we call the trimmed, 20% trimmed mean. So our new average is now 5.67. Suppose we continue this further and remove more of our data, we will eventually approach what we call the median. So as we trim it further, as we trim our data further, we will get an idea of where the center is located. And as we trim it further, we will approach what we call another parameter, another statistic used to measure the central tendency of our data, which is the median. So here the median is 6, the average of the two. So this always happens when our sample size is even in number. So we will have the median will be 2. The 2 at the center, because here we have 10. As we trim it further, we will have the 2 at the center, and then we will average it. So here luckily it's the same. But if our sample size is 9, suppose this is not included, we'll only consider up to this one, up to 7. So we will be left with, remove this 2, remove this, remove, and then we'll be left with 6. So our median is also 6. Right, you understand? So it depends if our sample size is an even number or an odd number. So for an odd number, we don't need to average it. Alright, so the next one is mode. So mode is the value most observed in our data. So here the mode 6 occurred more compared to the others, 5 3 times. So here 6 occurred 4 times. So our mode is 6. Alright, so mode, mean, median, mode. So if we plot our observation on a dot plot, it will look like this. So we observe 4 field goals once only. 5 field goals 3 times. Okay, 5 field goals occurred 3 times. 6 field goals occurred 4 times. 7 field goals occurred only 1 time. And then this 11 field goals. So the mode is the one that occurred more frequently. The median is, if we arrange it, right? If we arrange it, is the one at the center. So the median, unlike the mean, right? So again, the mean is 6.1. So the median, unlike the mean, is not affected by the outliers. So the reason why this is big is because of the effect of the outlier. So there, this is the mean. So what is mean? Okay, take a look at this computation. So again, mean is 6.1, so it is somewhere here. So if we add the difference of each of this with respect to the mean, for example, 4 minus 6.1, 5 minus 6.1. So 4 minus 6.1, 5 minus 6.1 times 3, because we have here 3, it occurred 3 times, and 6 minus 6.1. So we're measuring here, what we're doing is how far those that are lower than the mean, how far are those from the mean. So 4 minus 6.1, that's how far it is from the mean. And we're getting here a negative value indicating that it is left side, lower than the mean. So the sum of all the values, the sum of all the distances of this data, of these values from the mean, is negative 5.8. That is, we're considering the length, right? So consider this geometrically. Now the sum of all values greater than the mean, we only have here 2, 7, and 11. So 7 minus 6.1. 7 minus 6.1 is how far it is from the mean. 11 minus 6.1 is how far it is from the mean. The sum of this is 5.8. So as you can see, the mean, if you take the sum of this, it will add up to 0. So there you go.